Lesson 6.5, Properties of Special Parallelograms. This lesson starts out and has you kind of like justify or explain properties by asking some questions. So it says, what questions would you ask to determine whether each figure is a parallelogram? So if you're talking about parallelogram, what kind of things do you need to know? Think about angles, side lengths, parallel, opposite sides, adjacent angles, or consecutive angles. Think of questions, what would you ask to determine if it's a parallelogram? Part B says, what questions would you ask to determine whether figure 1 is a rectangle? Think about the properties of a rectangle and then kind of ask those questions. And then there's another one down here. Part C, if all figures are parallelograms, what is the most descriptive name for figure 3? So kind of think of, okay, well, what type of parallelogram would that be? And then you name it. Example 1, find the diagonals of a rhombus. A rhombus has a lot of features. It is a parallelogram, and it has all 4 sides that are congruent. So it says a parallelogram ABCD is a rhombus. What is the measure of these angles? Now, the solutions are here. You can look up the solution step-by-step explanation. But if you remember the properties of a rhombus, those diagonals will always intersect at a 90-degree angle. So if they intersect at a 90-degree angle, angles 1, 2, 3, and 4 would all be 90. And look at that solution. Take the time to look at it. Parallelogram JKLM is a rhombus. So again, another rhombus. How are angles 1, 2, 3, and 4 related? And it tells you, remember, JL is congruent to JL. JL is this side that they're sharing. So the transitive property, JL, is the same as JL. So think about it. You have 2 triangles like this sharing this common side, and the 2 side lengths, they're all the same because it's a rhombus. So all 4 side lengths are the same. So you have 2 triangles with 3 sides the same here and 3 sides the same there. These triangles are congruent by side, side, side. So if the triangles are congruent and these are isosceles triangles, it means the 2 base angles are the same. And this is isosceles. These 2 base angles are the same. All 4 angles would be congruent. Try this. What is WY? I'm going to write a few things on this board to see if you can understand this a little bit better. So if I have this triangle right here, and remember, I know this is a right triangle. And if this is 3 down here, then this up here would be 3 because the diagonals bisect each other. I can find this using the Pythagorean theorem. So x squared plus 3 squared equals 5 squared. And I'm going to go ahead and solve. X squared, oops, that's supposed to be plus 9 equals 25. And I'm going to subtract 9 on both sides. So I have x squared equals 16. But I don't want x squared, I want x. So I'm going to take the square root of both sides so I can get that x equals 4. But that's not what the question asks. The question doesn't ask for just w to this midpoint right here. It asks from wy. And if this side is x, this other side is x as well. So the total, I'm hoping you can get, it would be 8. Here's another one for try it. What is the value of the measurement of RPS? Now look at those triangles. You have an isosceles triangle right here. Well, on both sides, actually. Isosceles triangle here and an isosceles triangle over here. So these both, and if you know that that vertex angle is 70, and I'm going to turn it this way. Most students like the triangles facing this way. So here's this, so I'm just rotating it. Here's that 70. You should know that each of these angles down here are the same. That's what these are right here. Just rotated. Okay, so if you need angle RPS, these would also be the same because those angles are all going to be congruent. So think of a triangle. The total needs to be 180. So you have 70 plus x plus another x. And I'm hoping that you can solve for x. And remember, check your answer in here. Once you get that x, check it, plug it in, and double check your answer to make sure that you're right. Theorem 616. Now remember, you don't have to memorize the 616. Just remember that this is a theorem. If a parallelogram is a rhombus, then its diagonals are perpendicular bisectors. So they intersect at a 90-degree angle. All these angles right here are 90. And no matter what I do, oops, let me change this. No matter what I do to this manipulative, these side lengths, of course, are going to be the same because those sides are the sides of a rhombus, and all four sides of a rhombus are the same. So they're perpendicular bisectors. So you are bisecting this segment or diagonal and this diagonal as well. Here's another theorem. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. I love this visual because it really shows it. It's still a rhombus. Notice how these angles are all bisected, and opposite angles are congruent. So they're the same. So no matter how I manipulate this, those diagonals are still bisecting each of the angles. So we're going to actually do some problems with that information. A quadrilateral, ABCD, is a rhombus. So it's telling us this is a rhombus. What is the measure of angle ADE? So I'm going to have you think of those triangles again. We're always referring back to those triangles. That's why we learned them earlier this year. So if this is 53, this is 53. Oh, that's a really squished 53. And this is 53, and this is 53. Okay, so you kind of get the ideas, and there's all those broken up triangles. If I need ADE, this angle right here, I know that this is 90, this is 90, this is 90. All those are 90. So I have 53 plus a 90 plus that angle that I'm trying to get, which I don't know, I'm going to call x. That should equal 180. And I'm going to just highlight this triangle. So it's this triangle right here. That triangle right there. If I add these up, combine like terms, and subtract from both sides, you should get the value of x. This is a great example because it has some more algebra involved, and the more algebra we can do, the better off you'll be. So this is a rhombus. What is GH? Now, all these sides are the same. So if I can find HJ, then it's going to be the same as GH. But first, I need x. So I look at these. Ooh, this diagonal. Remember, it's bisected. The diagonals bisect each other. So I'm going to set both of those sides equal to each other. So I'm going to have 2x. Oops, let me get the pencil. I'm going to have 2x plus 3 set equal to the other side of the diagonal, 4x minus 7. I'm going to solve for x. So I'll try to do this to minus 2x on both sides. So I have 3 equals 2x minus 7. Again, I'm setting this equal to this right there. Add 7 to both sides. So I have 10 equals 2x. I'm in the home stretch. I'm finding x. I'm going to divide by 2 on both sides. And I should get that x equals 5. But that's not what the question asks. The question asks for this length right here. But if I can get this other length, it's going to be the same. Notice there's those tick marks, and I'll make them bigger so you can see them. Okay, so I have, oops, I have to erase it because now I can't see it. There. I have 3x plus 1 is going to be congruent to what I'm looking for, the GH. So I'm going to plug in my 5 and solve for that. And I'm hoping you can do that on your own. And there's the answer. Okay, the quadrilateral is a rhombus. What is MNO? All right, so I've got this 62, and I'm just going to mark it 62. This is also 62. This is also 62, and here. So I've got these 4 angles that are 62, but that's not the angle I need. I need this angle right here. So I'm going to take this triangle, this large triangle, put both of those two sides together, and I know that I've got 62 plus that other 62 plus the angle I need, which is x, equals 180. Okay, and combine like terms. Subtract from both sides, and you will get what x equals. X equals, and it says MNO. MNO. That's exactly what x is, and I'll just put the x here so you know that. And once you solve for x, you have the correct answer. Another problem, try it 2b. This one has a lot of algebra. The quadrilateral is still a rhombus. You need to find QT. So let's grab some colors here. QT is from here to here, which means this length, the whole thing, QS, is going to be double what I need, or QT is half of this measurement over here. Okay, so let's look at this, and it looks like I've got some measurements, and I know it's a little bit tricky. Let me erase this. This side right here, that side of the rhombus, should be congruent to this side right here on the rhombus. So let's set those equal and solve for y. 3y minus 1 equals 2y plus 3. Let's solve for y. Get y by itself. So I have y minus 1 equals 3. Add 1 to both sides, and we get y equals 4. But we're not looking for just y. We are looking for this total length, and then we'll cut it in half to find the QT that we need. So I'm going to plug in 5y minus 4. Plug in that 4 that I just solved. 5 times 4 minus 4. So I get 20. Subtract the 4, you should get 16. So this total length across this whole diagonal, all the way across, is 16. I just need half of that. So I'm going to let you do that last step on your own. Theorem 618, it says if a parallelogram is a rectangle, then its diagonals are congruent. So not only do those diagonals bisect each other, but they're exactly the same on both sides. And you can manipulate this to discover that. So they're always going to be the same lengths. So we're going to do a proof, but we're actually not going to walk through it the whole way. I want you to look at this, the solution, the step-by-step, and it actually goes through it. It goes through the solution. It talks about using congruent triangles, and then it goes through it. So take a second and look through these and to justify the reason why the diagonals are congruent. A carpenter needs to check a gate his apprentice built to make sure it is a rectangle. The diagonals measure 52 and 53. Is the gate a rectangle? Well, based on that theorem I just went over, the diagonals have to be the same, and if they're two different lengths, they're not. So it is not a rectangle. This is a fabulous application problem, so I'm not going to give you too much information because I want you to do this on your own. But basically, there's someone, Paul, that's training his horse to run a course, and it tells you how far he went, and if you look, this is a rectangle, so if this is 192, so is this. If this side is 80, so is this side. And then it wants you to figure out if he met his goal of riding 4 meters per second or faster, which means you're going to deal with distances to find the lengths, and you're going to deal with time or rate, so distance compared to time. I want you to try this on your own, and if you get stuck or struggling, use these to help you to hit the compute, go over it, and you can see your the solutions right here and the interpretation. Try it. A rectangle with area 1,600 meters is 4 times as long as it is wide. So I want you to draw this out. Just visualize it first. So an area of a rectangle. And remember, I'm freehanding this, so it's not perfect. This is a rectangle, and the area equals 1,600 meters squared. And it says is 4 times as long as it is wide. So we're just going to say this is the width. And this is 4 times the width. Well, think of the formula for area. Area equals length times width. Or some teachers say base times height. Either way is fine. So if I have the area of 1,600, my length is 4W, and my width is W, you would get 4W squared equals 1,600. Solve for W. So get the 4 out of there, divide by 4 on both sides. So you have 400 equals W squared. Take the square root of both sides and you will get what the width is. Now the question says, what is the sum of the diagonals? So if I can get the width, I'm like, okay, well, I've got the width. Let me switch colors here. That width is 20, which means this length is 80. Could you find the diagonal? Think of Pythagorean theorem. And I want you to try that last step. But my hint is Pythagorean theorem, you have a squared, b squared, and you're trying to find that c, or that diagonal length. Diagonals and angle measures of a square. Here's a square, and it says adding the two diagonals, you'll get 92. So if you divided by 2 or cut that in half, you could get what each diagonal is. Now, I want you to go through step by step with this solution. It basically goes through each of the steps and how you can find the area when you're just given basically the diagonals. It's a great problem. Try it number 5, example 5. Square ABCD has diagonals. So I'm going to draw this picture as soon as it talks about something that's visual and there's no visual. Make sure to draw it. So this is a square, best I can, freehand. Go ahead and put all these tick marks so you know. So it's a square ABCD. And you can go clockwise or counterclockwise and start. It doesn't matter. It's okay. So AC is a diagonal and BD is a diagonal. What is the measure of ABD? So I'm going to highlight that in a different color. ABD right here. Now think of all the properties we've gone over. This is a square. Diagonals bisect each other. All the sides are the same. Every corner angle, every interior angle is 90. And if I have this diagonal that cuts through the angles perfectly or bisects them, because a square is also a rhombus, the diagonal cuts each of the interior angles in half or bisects them. So these are the same across and these are the same across. Well, each corner is 90 degrees. Take that 90, cut it in half. Each of these would be 45. Now in this case, I put them marked differently, but because it's a square, they're actually all the same. So I could take off one of these little tick marks or just add it. I'll just add it here. So all of these are the same. They would all be 45 degrees. All right, the concept summary. This puts it all together. So rectangle is a parallelogram that has diagonals that are congruent. And hopefully remember that all the angles are 90 degrees and the diagonals bisect each other. But those were properties of a parallelogram we already learned. So the extra is that the angles are 90 degrees and the diagonals bisect each other and are congruent. Rhombus has all these properties. The intersecting angles of the diagonals are 90. Opposite angles, like across from each other, are bisected and congruent. Okay, and if the parallelogram is a square, then all those properties apply. The rectangle and rhombus and parallelogram, for that matter, all apply to the square. I hope that helped.